Welcome back. We've got the mass points, the constraints, wallet integration, mouse interaction, all the pieces. Now we put them together. In this episode we're gonna generate the actual glove. A glove is really just a grid of mass points connected by constraints, horizontal constraints to the neighbor on the right, vertical constraints to the neighbor below, pin the top row so it hangs, and gravity does the rest. So let's build that. Before we generate the glove, however, let's clean up how we create points and constraints. Instead of manually pushing two arrays, we add some methods to help us. First, we have a create mass point and create constraint method. Those create the object and add it to the right list, and then they will return the actual point or constraint so we can use this. This is just a little bit of a cleanup and it makes things a bit easier. Notice the constructor no longer creates any points or constraints directly. That responsibility moves to the playground. Also note that gravity is now 250 instead of 150. The glove is now heavier, so it needs stronger gravity to look right. The big change here is the constraint solver now runs multiple iterations. 3 in this case. Why? Because when you solve one constraint, it moves a point which might violate a different constraint. With a triangle, that wasn't a big deal, but with a grid of hundreds of connected points, a single pass is usually not enough. So multiple iterations are needed, and this let the constraints converge to a better solution each frame. So more iterations equals a stiffer glove, but more work per frame. I use 3, I guess, or I think this is a reasonable starting point for now. The constraint now checks if a point is pinned before moving it. This is important because pinned points are our anchor points. They hold the glove up basically. If a constraint tried to move a pin point, the glove would sag unevenly or fall apart. So now only the non-pinned end moves and it absorbs the full correction. Also, the draw method now uses a line thickness of 1 instead of 10, since we will have hundreds of constraints. With hundreds of points, drawing every single one as a filled circle would be a little bit noisy, so we only draw the pinned points now, the anchor points along the top, basically. The glove itself is visualized by the constraint lines connecting them. The constructor also changes. It now probably sets is pinned equals to false for normal mass and is pinned equals to true if the mass is 0. And now to playground chairs, because we need to actually generate the glove and connect all the constraints and points. So we define 3 parameters. Glove resolution is the spacing between points and pixels. Glove width and glove height defines the size of the glove in pixels. A resolution of 7 means roughly 800 divided by 7, so it equals to 114 points across. 200 divided by 7 is 28 points down. That's over 300 mass points. First, we create all the points in a 2D array. The offset centers the glove horizontally and places it 50 pixels from the top. Every 10th point along the top row gets pinned, plus the last one. So the glove hangs from kind of an evenly spaced anchor points. Then we connect them with constraints. Each point connects to its right neighbor and its bottom neighbor. That gives us a grid of structural constraints. The if checks make sure we don't get or go out of bounds on the edges. The update method also now gets a fixed time step of 0.02. This is just for me. You can of course set delta time, and it should work also quite fine. But make sure you have the improved verlet method activated or integration activated. And yeah, that's it. What we built today, as a small recap, we generated a grid of mass points connected by structural constraints. The top row is pinned at regular intervals to act as anchor points. We added factory methods to simulation for cleaner creation, constant solver iterations for stiffness, and pinpoint awareness in the constant solver. We also updated mass points to only draw pinpoints. And yeah, that's it. You can now grab any point and drag it around, and the whole glove should respond as in this video. What's coming next? In the next episode, we are adding the ability to break and cut the glove. We will add a breaking threshold to constraints so they snap when we stretch them too far, and we will add right-click cutting so you can slice through the glove with the mouse. And yeah, that's it. Thank you very much for watching, and see you in the next one. Bye bye.